So GHKL represents the lattice point in the reciprocal space. All right, so that's all for this chapter, which is about the reciprocal lattice. I also prepared a few questions for the tutorial. This first question, second question, and third question. Okay, there are 4 questions. Okay, there are 4 questions. So because these questions are a little bit complicated, so I decided to discuss the answer with you lah. Okay, so the first question, I asked you to show that the Bragg law can be written in terms of the reciprocal lattice vector as 2k dot g plus g squared equal to 0, and k is a wave vector and g is a reciprocal lattice vector. I think we have discussed the answer for this question in last chapter, chapter 5. Yeah, chapter 5. So if you have any question regarding the answer for this question, for this tutorial 1 question, you can refer back to the previous video recording lah. Okay, so I'm not going to discuss this one again because the answer is very straightforward. So now, number 2. I asked you to show that the HKL plane is perpendicular to the reciprocal lattice vector GHKL. How to do this? How to solve it? I give you 20 seconds to tidy up your mind and to try to think about this. Okay, I will give you 20 seconds. Okay, in order to answer this question, you need to know how to prove 2 lines are perpendicular to each other. Okay, so we can use the vector to prove it. And how to define line? Line basically you need at least 2 points. Whenever you have 2 points, then you can define it as a line. Okay, whenever you have 2 points, then you can define it as a line. So okay, I repeat again. We want to prove that 2 lines are perpendicular to each other. How to prove it? We can use a vector. Let's say A dot B. If it's cos 90, then you will get 0. Okay. Then if A dot B, you get 0, then I can say that these 2 lines are perpendicular to each other. Correct or not? When A dot product with B, you get 0. That means that A magnitude times magnitude B times cos theta equal to 0. So the only possibility is that this theta is 90 degree, which means that A and B are perpendicular to each other. All right, and then the next thing is that how we need 2 lines, right? We need 2 lines. Then how do we define the line? Line means that as long as you have 2 spots or 2 dots or 2 points, then I can define it as a line. Okay, I can define it as a line. So now, how to define plane? To produce a line, you need 2 points. To produce a plane, you need 2 lines. So whenever you have 2 lines, I can say that, okay, this is the plane along this direction. Okay, if you can't understand this, think about it. Whenever you want to define a plane, you must at least have 2 lines. Okay, as long as you have two lines, then you can define the plane. So when we have two lines or two vectors, then we can define the plane. The crystal plane with the Miller indices HKL is a plane defined by the point A1 over H, A2 over K, and A3 over L. Then the two vectors that lie in that plane may be taken as A1 over H minus A2 over K, and the second plane will be A1 over H minus A3 over L. But each of these vectors gives 0 when you get the scalar product. That means that when these two get 0, that means that you will get cos 90. Then you can say that these two vectors are perpendicular to the plane. Okay, so this is the answer. But I believe after I give all this answer, you still cannot understand, right? Okay, then I give further explanation on this. Okay, so this is a plane, right? This is a plane. How do I define this plane? How do I define this plane? I need to get at least two lines, right? If I know that I know the vector for this line and this line, then I can define this plane. Or if I know the vector for this line and this line, then I can define the plane, right? Okay, okay. This spot basically is A over H. A over H. This spot is basically B over K. This spot C over L. Why is A over H? Give you 5 seconds to think about it. Can or not? Let's say this plane is 2 plane. 2 plane means what? Means that this is half, here is half, here is half. Right. HKL equal to 2 means that A equal to 1 over H equal to half. B equal to 1 over K equal to half. C equal to 1 over L equal to half, right? So in the real lattice, this is half, this is half, this is half for the 2 plane. So HKL equal to 2. When H equal to 2, the real lattice equal to half A because 1 over H. Right? 1 over H. Or you can also write it as 1 over H A. Okay?